I know my grandma traveled a lot. She like did a ton of cruising, and she had a joke. I mean, I think it's kind of a classic joke, but it was like a European joke where it talked about in heaven. Have you heard this? Where it's like, and I don't know all the ones, but it's like in heaven the I forget. No, it's like the police are German and the food is Italian. No, I don't know. Or the food is French. I don't know. They have, there's like, it's like a list of 7 things, and it's like, okay, in heaven, this is where all the, and then in hell it was like the British are in charge of the food. And I think the Italians were the police, or and the Germans were the comedians, or I don't know. Yeah, I forgot. It's a good one. So anyways, you'll get to experience shaved beef and a lot of gravy. So in the last little part of class, if you have a laptop device, it'd be pretty not required, but if you have one, it'd be super useful for this. We are going to learn a little bit of statistics, regression specifically for you to do that empirical project 2 and the last house price data project. So first, I'm just gonna pull up. This is me a little wacky, but I'm gonna pull up Paint. And you don't have. You're gonna watch me for the second here. I want to have a little doodle that I can do on the big screen. Except for why is my should have like. Oh, there it is. Boop. Right, I just want to have something I can draw. Okay. So let's imagine that I have. Ooh, wow, I zoomed in a little much there. So let's imagine that I have like a plot, right? I have a plot like this, and I have some data, right? So I'm just going to draw some. So this is maybe Y, and this is X. Well, and let's make this real. Let's say, hold on, let's do something. So let's say we have, income, household income, and social capital, right? And these are cities in the United States. So we know, right? We know we don't have this data exactly, but we know roughly speaking that as social capital increases, right? So as I'm putting dots higher up in social capital, that ultimate income starting with in the low end earners tends to increase. So I'm going to just put some dots on here, right? Imagine this is our data. So we just have a bunch of random data, but there's broadly speaking a trend here, right? So if I was to draw a trend line through here, I would, maybe, and I can even get out the line and just say, well, it would look roughly like this, right? If I wanted to connect to these two, it would look like that. You've seen these scatter plots before. And the idea, right, is that every increase in social capital has a certain corresponding amount of increase in household income. So let's think about that in terms of an equation, right? So we would say, right, I'm predicting household income. So I would say household income is equal to some number, right? So traditionally we say we do beta, Greek letter beta. So we have beta times the social capital numbers, whatever those are, and then possibly an intercept, right? So then there's this other constant or whatever. And the idea is this number, right? This number here is chosen, actually these two numbers are chosen to make this line awesome, right? Like if I let me draw a bad line, right? Maybe I could say, oh, well, this should look like this. Okay, well, that's a bad line. You could see this is like, there's a lot of error here. There's a lot of error here. It sort of is okay, but this one, the dots are tighter to the line, right? We would have less error if I used the light blue model than if I used the one I just did, right? So, and if you remember from your 9th grade algebra class, right, lines are y equals mx plus b, right? They're dictated by a slope and an intercept. So all these linear regression models do is just give you a slope and an intercept for your variables. Right? It just tells you, well, okay, how much does this change when this changes? Just yet again, like rise over run, same deal. For the run of social capital, what's my rise in household income? So it's really very simple. We're just literally drawing lines. But the idea is we're drawing the line that minimizes the error in predicting our household income here. Now, normally when we draw these just abstractly, that's why I started doing it this way, we would say y equals, oh, that's going to be really annoying. Get the pencil out. Y is beta x plus beta 0. Right? So these are just these unknowns, right? And we're just making a line, and we pick the betas, we pick the unknown numbers to be the best one to minimize error. To be the best to minimize error. So I want to show you how that works in practice in an Excel sheet. So here I'm going to here's a new one. And if we go to Moodle, I have in the lecture for today something called linear regression in class. I'm going to click on it. And, let's see. So here we go. So I've got some data. So here I've done this abstractly, right? I have y and I have x. You'll have, I think, something similar if you open up yours. I'm just going to copy and paste this, right? So I'm going to copy and paste this into my Excel sheet.
We don't get that. We don't get that. Attempt quiz. We get a quiz.
Oh yeah, you can attempt the quiz. Yep, just attempt. It's a quiz, but it's not. Yeah, sorry. Yeah. Anything that has buttons is a quiz in Moodle. Sorry, it's just called a quiz if you can answer things. Okay, so I've got some data here, right? I've got some data. And I want to make a model, right? So I'm going to have my beta 1, the one that's the slope, and beta 0. So if you eyeball this, like go ahead, I want your help here. If we look at y and we look at x, if I was trying to predict y with x, what would I do? Like how many, like x times y equals y, roughly? It doesn't have to be perfect. We just want to guess. 1.5. Does that look good? Like roughly 1.5? Okay. And then if it's 1.5, what would be the intercept? 0? I guess we're pretty close to. You know what I mean? Like we just need an intercept. Okay, sorry. So if I take 22, let's just start with the first one. Yeah. 22 times 1.5 is 33, right? Yep. So that's too large. Okay, so if we make our intercept -2, it would work out perfectly. You see how that is? 1.5, -2, right?
We have 20 and 19. Yeah, I think everybody gets different.
Yeah, you guys hear different numbers than me. Yep, it's just scrambled. So we want to work on mine right now.
Okay.
So for mine, I'm going to guess, based on your input, that my slope is 1.5 and my intercept is -2. So if I do that, right, my model is y equals mx plus b, right? I'm going to lock that in, right? So this is F4 on a Windows, it's Command T on a Mac. That number, 1.5, y equals mx, right, plus intercept, b. Lock that in. So my prediction using this model is that y would be 31. It works perfect, right? So for the first data point, I am correct. Now if we go to this one, am I right? No. Is this one right? No. Right? So I'm not going to be perfect, right? This is just a model. But I have a prediction, right? I have a prediction for all of these. See how that goes, right? I have a prediction. So I can calculate how wrong I am. Right? So my error is just going to be my data minus my prediction. So I'm going to get a bunch of errors. Some of them big, some of them small. And in fact, if I want to, I can even, let's do this like, let me just show you a picture of this, right? If I graph these, is this the right way to do this? This might not work exactly how we're thinking, but I'll try it. Nah, that's not. I think I need to move, oops. Yep, so I'm gonna move, yeah, it's fine. Maybe I'll move, hold on, let me see. If I move this, oops. If I move this over here, move this here. I'm just moving some stuff around real quick to get a nicer, I think actually, I think I want, oh. Let me see if this does. This part isn't necessary. I just want to get a picture. I think this will work. Insert. Yeah. So you can, hold on. Almost. I'll just do the dots. Only dots. There we go. Okay, you can kind of see it. So the blue dots are the Y that we're trying to predict, and the orange dot is our prediction, right? So if you look at our line, is our line pretty good? Is that slope about right? It's pretty close, right? If you were to change the intercept, would we shift that line up or down at all?
Yes.
Which way would you shift it? Down a little bit, right? It looks like it's just a little too high. Again, we eyeballed it, so whatever. But, we got pretty close. So what we're going to do now, though, right, is we're going to figure out the best possible line. Right? We're going to do the best possible line. And the way that will work is we've got these errors, right? Now, I want to minimize these errors. Now, the problem is if I just add up the errors, the negative errors are going to cancel with the positive errors. Do we want that to happen? No, right? We don't want errors to cancel. We need to get rid of the sign. So how do I get rid of the negatives in this column? Is there a mathematical way to get rid of negatives?
And positive.
Okay, so just drop the negative sign. So there's a mathematical function that does that. It's called absolute value, right? Absolute value. We're not going to do it that way. We're going to square it. Don't ask me why. There's a linear regression squares it. That's just the reality. There is a model where you drop the negatives. It's called median regression. We're not doing that. So the way we're going to drop the negatives is square it. So we're just going to do that. Squared. It gets rid of negatives. And then we're going to add it up. Right? So sum. Oops. Add up my errors. I've got 112 of error. So what if I change B0 to be -3? Oh, my error dropped to 91. See how that is, right? So by changing my intercept to be -3, I dropped my error from 112 to 91. Right? And if I go to -4, it's gone back up again, right? So what about -3.5? That's not as good. -2.5. Not as good. Okay, so -3 is kind of the sweet spot. Now we could mess with this for a while. But Excel has a way to just do that really fast, right? So if I go to Solver, it's an add-in you can do. Yeah, and you won't need Solver to do what we're doing actually, because Excel actually does regression out of the box through a different package. You just push a button and do it. So you won't have to do it this way when you do it. You're just going to tell Excel to do it and read the output. But I want you to know what you're doing. This is me showing you what's actually happening under the hood, if you follow me. So you're not going to be making these sheets with predictions and errors and stuff. You don't have to do that. But I wanted to do it with you so you could see it. So we're going to minimize the error, right? We're going to minimize the error by changing these things, You see how that works? I'm going to mess with these to make the error tiny. And, oops, that's a different thing. Let me close this. Oops, whoopsie doops. That's weird. Let's try again. Data, solver. We want to minimize the error. No, we want to minimize that one. That's why, wrong thing. There we go. We're going to minimize the error. I was clicking on the wrong cell. Okay, so it turns out that the best line had a slope of 1.66 and an intercept of negative 5.8. So it turned out that we actually needed to tilt a little bit up and shift down a little bit. And that gave us the best line. What does that mean, though? So that would mean if y was income and x was social capital, it would mean every point of social capital, whatever the units are in that variable, would create a 1.66 increase in household income. So if we increase social capital by 10,000, we'd get 16,000 of income. Just by virtue of the slope, right? It's again rise over run. So that's what this is. So I'm going to show you how to actually do it with Excel, where you just tell it to do it because it's easier. But the principle of it is to just make a line that's best line through the data that minimizes the error.
Now with this project, are we actually going to be trying to formulate the hypothesis first and then just going through the data that we're accumulating and to see whether or not that's going to support our hypothesis, or are we actually going to be, analyzing the data to, you know what I'm saying?
No, then yes. Okay, let me explain. In empirical project 2, I give you the hypotheses already. You're not formulating anything. It's sort of like I spoon feed it to you because I tell you here's the 5 variables to check.
Okay.
Right? In house data project, you come up with the hypothesis, including the data that you think will be relevant, and then you'll use this to confirm or deny that hypothesis. So.
Oh, okay. So in the third project, we are kind of formulating the hypothesis first, and then determining at the end based on the data if it's going to be a good one or.
Yes. Oh. Yes. I mean, I guess technically you're doing it for both, but for the second one, it's not your job to come up with it. I tell you it. And the third one, it is your job to come up with it. Okay, so so the way to actually do this, and this is where I want you to follow along because this is the way that you'll be doing it, is so you're going to go to File. Now, anybody on a Mac? No. Okay, so we need the data analysis add-in. So that's what we're going to put in right now. So it's File, Options. And again, right, I'm recording right now, so if you are at home and you need to do this later, you can look at it. So File, Options, Add-ins, and then this is the weird step. You can see it right here. Doesn't matter. You want to click Go down here and then check this box. Now, I already have these checked, so yours will probably look like this. So then you want to check. Really, you only need the analysis tool pack. I use Solver a lot, so I just always have it installed, but it doesn't really matter. You won't need Solver for our stuff, no. So analysis tool pack is the one, the top one. I'm going to just hit OK. So where that will show up is in your data tab. So here in the data tab, I now have this data analysis thing. And that's the one we're going to do. So you'll see, so I'll click on data analysis. And if you've already pasted your data, you can too.
Wait, where did you get the data analysis?
It was under the data tab. On the far right. Now, did you do the whole File, Options, Add-ins, Go, check the box and hit OK? This doesn't show up unless you do this whole process thingy. Is it there or no? If it's not, I'll come help you in a second because I can get us going and then we can get there. So, so under data, you go to here. Now, surprisingly, right, the thing we want in here is regression. It's actually in there by name, right? So you click on the regression, and you're going to get this like dialog box, right? Yeah.
When you clicked on data analysis, you clicked on something else, right?
Yes. So I clicked on regression.
No, before to get that box.
Oh, sorry. So data analysis, which gives me,
Takes you straight there.
yeah, should. And then you go regression.
No, it's spinning. Okay, there we go.
Okay. So you'll see it wants some stuff, right? It wants some stuff. It wants the Y range. So in regression lingo, Y is the thing you're trying to explain. So in our case, we have a Y already labeled as Y. So this is how I like to do it. If you click on this little thing, right, it shrinks this box and lets you point at stuff. So this is a little Excel trick here. If you click on the top and then do Control Shift down, it highlights all of the data and stops at the bottom. That's really handy navigating Excel. Saves time. So I just did Control Shift down, and then I'm clicking on this box again. And now, right now I have all of that column selected, right? B1 to B16 is where my Y's are on my sheet. So you just want to draw a box around your Y's, and then draw a box around your X's. So I'm going to do the same thing. Left click, Control Shift down. Click this box again. Okay?
Does it matter that the header is in there?
It does, right? So I included the header, right? So because I included the header, I need to check the labels box. That's the number one way to mess this up. I'll tell you right now. If you put labels in and don't check the labels box, it will say non-numeric data die, right? It'll be bad. Even worse is if you don't include a label and then you do check the labels box, it will take your first line of data as a label and then give you wrong answers. Okay, so number one rule with regression is know whether or not you should check the labels box. In general, I would say always select your labels and then always check the labels box. That's the best way to do it. Okay, now for prettiness, I'm going to click this line fit plot thing. It doesn't really matter if you do or don't. I just like it. New worksheet's best, I would say. And that's it. You just draw your two boxes and click OK. Now, and then I have to explain how to read this stuff because you get some things. So you'll see, right? What do you notice here? Here's this picture, right? This should look pretty similar, right? This is basically the one we got by eyeballing it, just slightly different. Okay, now I'm going to zoom in over here. Right, so here's our slope and here's our intercept. So what do you notice about these? Right, here it says coefficients. What did we get? 1.66 is negative 5.8. Does that sound familiar? Right, those are the exact same numbers we got. Minimizing error using solver. So it's again, that's the method it's doing behind the scenes, is minimizing those errors. Now the trick is to read this, and the number one place you want to look is here in p-value. So I'm going to highlight this in a gross color. Let's not do gross. We'll do green. Okay. So the p in p-value stands for the probability that this coefficient is not 0 on accident, like by randomness. There's a lot of statistical subtlety, right? There's probably 40 years of fights in an academic community buried in this p-value. So there's a lot of issues I'm going to gloss over. But for your purposes, understand that it's approximately true that this is the chance this was just a mistake, right? Because again, random data is going to be different randomly. Okay, but we got a slope of 1.66. What's the chance that 1.66 got to be that big by random accident? The answer is 0.0000000353. Okay? Are we comfortable that that is a small probability? Yes, right? That is a very small chance this was just garbage, right? So what does that mean? That means we can conclude that there is a meaningful connection between X and Y in this case. Moreover, that our best guess of that connection is every increase in X by 1 causes Y to go up by 1.66, right? In fact, the 95% confident of that connection is somewhere between 1.4 and 1.92. Right? So there's some wiggle room in how much we think it goes up or down, but we're confident that they're connected in a positive way. Okay? That's the number one place you look when you look at these, right? So if I was doing my house price data project, right, and I'm connecting Hillary Clinton vote share to increases in house prices, and my p-value is 0.43, what does that mean?
43% chance that it's wrong.
Yes, right? That, this could have been negative if they ran it again on a different day, basically. Not the Hillary one. This one could have been 1.5, it could have been 1.8, but it's working, it's positive, right? So another thing that we would say in the academy, right, is there is a statistically significant relation between X and Y at 95% confidence or whatever, just because that p-value was under 5%. So really look at p. If it's under 5%, you've caught a fish, right? And if it's over, you have a boot or a tire or whatever you want to do.
Right, so if I have 0.37, then I have a high percentage error.
Yeah, so you are 37, there's a 37% chance the connection is fake, and so you would not claim that there is anything going on.
Even though,
No.
the plot looks good though.
Right, so often what happens, right, is maybe you get a big slope, but there's a huge cloud around it, Oh, sorry, so what you've got there is this line passes really close to 0. So you're not confident this doesn't cross the corner here. You are confident it's
Yeah, the slope is different.
Yeah, the slope and the intercept are different, right? So you're very confident that this thing is sloped at like a 2,
Okay.
but you are not confident that it's sloped at like 0.94, right? You're not confident that it doesn't pass through 0, which is fine. I mean, it's okay for it to pass 0. Mostly, we almost never care about the intercept at all. The only time we use it is to like predict values, right? It's almost always about the slope one. We want that one to work if you're trying to conclude something. Okay, so you can go ahead and try it actually. So you've got your own data, right? And I think and what does it want on the thing? It says enter the T, so that's this thing, right? So I would copy this and paste it there. And if you've done it right, it should turn green. See how mine's green? If it's wrong, it'll be pink. That way you just know that you've done it right. So let's go ahead and try that if you've got your own little laptop there. Otherwise, for people that are still trying to get Excel up and running, I can float and...
I got it.
You got it up here, you're good? All right. So let's go ahead and see if we can get some green.
Are these
So
all
I'm grabbing-
the same? They're just
I'm
different.
grabbing the X value.
They're scrambled.
Yeah.
Oh, the
No, I'm
first,
saying
sorry, the
like-
first 4 are same style, yeah.
Okay.
Then down with the last 4, we're using real data. It's actually a restaurant thing. We'll get to that later, though.
Today?
Yeah.
Okay.
Yeah, so, but you might actually get one, I'm assuming.
Yep.
Yeah, I wouldn't bother doing it. Yeah, it's just-
That's what I do.
So you can actually read these and maybe take a peek at them. Because the restaurant data is up on Google.
Oh,
Give
maybe
it
I
a
should
shot.
do it again.
Zeb, you had me put it 230, right? Or no, I don't remember. Do you have any for stats?
No, I didn't.
Oh, who'd you have for
That
statistics?
wasn't, this is why I did that.
Okay.
That's the way we did it first, and then I said,
It might have been in it.
Right, but let's look at
Okay.
it. How do I know this is?
Yeah, I don't know all the
That's
pieces.
X.
Oh, you're green, we're good.
And how can I
Did
tell
you get it? Did you get all of this?
Yeah,
efficiency.
Yeah, that's good.
Okay.
Did you get one yet? Did it work?
And I'll do.
Uh-huh.
yeah.
Okay, good. I'm just making sure that it's worked at least
Yeah,
once.
analysis.
Did you guys get it to work once yet?
Well, and I'm going to do it again because it did not work when I did mine. So, select my data range. I'm gonna do it all the way out here.
Perfect.
And then I'm gonna do this one. It's there. And back here, I'm going to do the labels. I've got a cell here. I'm just gonna put it in this one, instead of putting it in.
You just ruined it. I mean, redo the X there.
Got my X. Go back. Now,
I like to do just do your worksheet. You can have it like display in a
and then
particular.
it does that.
I think that's fine. I think you can push OK. I think you're good now.
Okay, so this shoots me out another one. Oh, and this now gave me a different P value. Maybe I hit it backwards, yeah.
Oh, and it asks for the T actually. We look at the P, but it wants
Oh,
the
it's a
T.
T.
Yeah, if you go to,
Okay, maybe that's what I was doing wrong. Yeah. I would get, I took P as just T.
And the only reason I ask for a T is because
There you go, check.
numbers near zero, it doesn't like, yeah,
Bingo.
you got it. And you got one already, right?
Yeah, and so, do we have to do all the rest of them?
No,
Okay.
no, this is not graded. This is just for us to do together. Okay, let's do this on some real stuff. I've got some restaurant data here. So we are, if you go to the course page, I just opened this in a new tab so you don't have to leave your quiz. It's fine if you do, but it's just easier if you don't. There's this thing right here. It says Zaggett's Restaurants. So if you know Zaggett's Guide, it's like a real restaurant guide. This is data from, how many restaurants is it? I think it's 100. I think 50 in the suburbs and 50 in the city. Yep. So here's the data, and you can see right, every restaurant is scored on a 25-point scale for the quality of the food, the quality of the decor, and the quality of the service. Okay, and some are in the city and some are in the suburbs. So let's do our like real people wisdom intuition thing and say if I was trying to predict the cost of my meal, what do you think is going to predict whether my restaurant meal is expensive or not? Is it going to be the location, right, city versus suburbs? Is it going to be the quality of the service, the quality of the decor, or the quality of the food? The food, right? The yummier the food, the more expensive the meal, right? More expensive. It's not the opposite, right? Cheap food isn't amazing and expensive food is gross. Okay, so more expensive the food, the better the food. That's one prediction. And the other stuff won't work, or will also work, or what do you think?
well, I mean, location is gonna have a big impact.
So you think if you're in the city, your
It's gonna be
cost
more expensive.
is going to go up. Okay, so maybe city will make it more expensive. What about decor, quality of the decor or service? Maybe not so much, whatever. Okay, so let's go ahead and check it. But at least as a class, maybe the consensus is that food is most important, and then location is maybe also important. And the other stuff should be less. Okay, so let's go ahead and check it. So first, let's do food, right? So what I'm going to do is same thing, right? Data analysis. And we're going to go to regression, and which is my why? Am I trying to predict food quality, or am I trying to predict cost? Cost, right? So I'm going to click on cost, do Control-Shift down. So I'm predicting cost, and what am I using to predict cost here? Food, right? So the first one was food. So we'll start with food. So we want to predict cost using food. Everything else is good. Let's go. There's our little picture. Does that look like it's working?
So you did it compared, I missed that, did you do it compared to anything else you did to location?
Oh, nope. In this one, I only did food. I predicted cost using food. That's all I did.
You put it in just y-axis?
Right, okay, right, so which did I put in Y? Everybody remember what was Y?
Cost.
Cost, because that's the thing I'm trying to explain. Okay, does it work? Does better food cost more? Is there a positive relation between food and meal cost? Right, where do I look? Remind me, where do I look to know whether that's true or not? What cell? What's the title? P-value, right? Or T, but they say the same thing, right? I want to look at p-value, and what do I, if these things are connected, what would be true? The p-value for something would be something. The p-value for food would be low.
So the p-value here is
Yeah, so the p-value here is 0.0000758. So is that small? Yes, right? So does better food cost more? Yes. Right? And in fact, right, we can see a $30 meal has a food score of 15, and a $60 meal has a food score of roughly 28. So there's quite a big difference in the quality of the food based on cost. Okay.
No, there's kind of a large spread in that.
Mm-hmm. Yes. And don't forget, there are other things maybe that we did not include in our analysis, right? We only did food. And this is important to know in a regression. If you leave out stuff that is relevant, your estimates are biased and basically wrong, right? So because we've left out variables that we know are relevant, this is basically garbage. So the answer to this question can actually change as we do the analysis more appropriately.
The R-squared is pretty low,
Yes.
relatively speaking.
Okay, and now this is important also. So this R square, this is the percentage of the variability in food cost that's explained by food. Right? Our R square is 14%. So there's basically 85% of the cost of the meal is currently unexplained.
where you get R squared?
Upper left-hand corner there. B5.
Oh,
Okay. Which means you would not want to use this model to try to predict your meal costs. Right? If you said, oh, restaurant A has delicious food, don't wander into a restaurant and assume that means it's expensive. Because you can't use it for that. It's not accurate enough for that. It could be cheap. It could be ridiculously expensive. Right? You could get bad food at a really nice restaurant for house and popping. Right? So you never know. And that's what that R square tells you. If the R square is 99% or 95% or something, then you know, right? Food will tell you basically exactly what your price will be. Or if you know the one, then you know the other. Right. Okay, so let's try a different one. So let's go ahead and do what? Let's do decor maybe. Or no, we were going to do location, right? So I'll go to data analysis, regression. So we're going to predict cost. And now you have to give it a number, so that's why I have coded location. It's just a 1 if you're in the city and 0 if you're in the suburbs.
Do y as
Cost and X as location. And so, sorry, this is something dangerous and really important. You absolutely 100% Uber cannot put a 1-0 variable in as your Y. It will break. It will give you garbage. It will be bad. Okay. You can do that. You need a different model. So logistic regression predicts 1s and 0s for the Y. We, however, have our cost is not 1, 0. So we can use a 1 and a 0 to predict cost. That's fine. But the backwards does not work. Okay. Just so you know. So don't ever predict a 1 or a 0 using regression. If you're trying to predict 1-0, come to my office, I'll tell you how to do it. But we don't know how to do it. Okay. But we're not, so it's fine. So we're going to predict it. Let's see if it works. Okay, so there's our Blobs, now our line is kind of dumb because there's only 2 spots. But did it work? Are we 95% confident that meals are more expensive in the city?
Because the R value is,
Oh, okay, wait, okay, careful. But where do we look?
or
Where's the number one place we look? P-value.
p-value.
Right, and what do we want p-value to be?
Low,
Low, it's particular under 5%, right?
right now it's at 3.8.
We're at 3.8, so did it work? Yeah, not fantastically, but at a 95% standard, it worked, right? And in fact, how much more are meals in the city?
Is that the coefficient? 5.2?
Right, 5.22, because remember, our x's are either 1s or 0s, right? So if you're in the suburbs, it's 0 times 522. If you're in the city, it's 1 times 522. So $5.22 is the exact increase in meal cost in the city.
Show me that again, I'm not following that.
Right, because our model looks like this, right? It looks like it looks like cost equals 5.22 times coded location plus 4206, right? That's our model that we estimated from Excel. And this coded location is either 1 or 0. So when it's a 1, it kicks in an extra 522. And when it's 0, it's 0. So your suburb meals cost $42, and your city meals cost $47.25, roughly.
So tell me what the equation is again.
Yep. So in general with regression, right, it's y equals mx plus b, right? And we're estimating m and b. So looking at that sheet, right, we know y equals 5.22 x plus 4203 or 6 from here. Right? Because we figured out the m and we figured out the b from Excel. And then in this case, x is either 1 or 0 because of our data. It was weird. In general, it's like whatever the food score was, right? 22, 18.
So even though the p-value is less than 5%, we're saying this does not have a strong correlation.
No, it does. Nope, it does. Yep. So we would say there is a statistically significant increase in meal costs in the city.
So because that p-value is higher than food costs, is cost a more relevant factor?
Ah, great question. Yes.
I mean,
So because this p-value is much higher than the p-value was for food,
Yeah.
we would say that food is a more reliable predictor of costs than location, city location. Right, again, it's hard to be an accurate predictor when you only have one, like you're either in or out, right? And maybe if we had how urban are you, it might work a little better, but yeah, food is a more reliable predictor of cost than the city is. Okay, so now let's do this for real. So the real model, right, is actually we want to include decor, service, food, and coded location all at once, right? Because those all are relevant. We want to have them all in. So our new model is going to look, right, so now we have, our new model will look like cost equals beta 1 times food plus beta 2 times decor plus beta 3 times service plus that intercept. Oh, actually beta 4 times coded location and then plus the intercept, right? So we've got all these different numbers that can predict cost. So in a regression, in a multiple regression, that's where you do more than one variable to predict your y. So that's what you're going to do in your empirical project 2. You probably will not do that in the house data project, although you can, right? If you have 2 or 3 things you think predict house prices, you can use more than one, but yeah, we just want to connect all of these up with costs. So to do that, it's the exact same process. So what we do is we go to regression, And we do the same thing we did before, right? Cost is still here. But instead of just picking E or just picking B, we're going to pick all of it, right? So I'll pick all 4 of these. I'll select all 4. So now I have 4 different variables that are all predicting the Y. Okay, so Excel can do that. You just have to make sure your columns are next to each other, right? That's the rules. They just have to be next to each other. Okay, so everybody see the setup here? I'm going to predict cost using food, decor, service, and coded location. All 4. And let's see. So we thought food would be best, coded location would be second, and the other 2 would not work. So we'll see what we get. All right, so our whole model, first of all, just real quick, our whole model is explaining 52% of the variability in cost. So we're not too bad at predicting restaurant cost, actually. I mean, it's not perfect, but it's not terrible. Okay, so which of the 4 things was the most reliable predictor of food cost? Do we agree? Decor is best? Right? You're totally correct. Why? P-value has the lowest p-value, right? 0.0000797.
Why is the p-value for the coded location different than when you calculated it the first time?
Ooh, that is a great question. Does anybody care to answer it? Anyone know why it's different now?
They're kind of relative to each other now.
Yes. Well, and there's a little. Think about it this way, right? What if food in the city was better than food in the suburbs? Well, now my coded location model has this extra thing floating around that doesn't perfectly match. So it's kind of like we were trying to do 4 variables job with 1 variable, and it's not going to do it so great. So from the perspective of coded location by itself, food quality, decor, and service is all noise, right? It's like randomness of the universe out of our control. And so the model sees these cost changes and it doesn't know why, right? The only thing we're using is, hey, look, I see skyscrapers. Wow, this restaurant is really cheap. I don't get it. Well, it's because it's a truck on the side of the road. That's why it's cheap. But we didn't include that in the model. We just put the address in, right? But if you include these other things like decor, it's like, oh, well, it's a truck. So decor is -10. And right? So what's happening here is that because we've included these other relevant variables, coded location is now able to more accurately work because it's not trying to do a bunch of other stuff that it can't actually do well.
And the relationship changed. So the p-value for food when run alone was lower than the p-value for coded location when you ran alone. So those relationships switched places as well.
Correct. So and then, right, so which was right? The old model or this model? This one, right? So again, if you leave stuff out, you get biased answers. So in particular, right, it is likely that high quality food was to be had in the city. And so we got food predicting cost when in fact it was actually the cityness of it that was doing it. Right? So once you scrub out the location and the service of the decor, the food isn't working, right? You get that? This is not working. This is way above 0.05. Right? Food is not a predictor of cost at all.
And doesn't the R-square sort of kind of point you in that direction and say, well, yeah, the p-value is low, but R-square is really low too, which almost tells you there might be something you're missing.
Yes, that's very true, right? So basically, this is. I mean, we would probably leave it in for completeness sake, and really, I mean, that kind of matches our personal experience, right? If you go, I mean, how many restaurants do we know that are holes in the wall that have like amazing food, right? And they're probably fairly cheap, right? You know, right? I mean, so iguanas, I love iguanas. It's amazing. I would not describe this decor. The decor score would not be high, and you don't even have a waiter, so service would be like 0, right? It's like McDonald's, right? So this is not a high service establishment, but it's delicious and it's cheap, right? Anyway, yeah, and Freight House. So here's the other thing: which costs more, decor or service? Right, if I want to increase my decor score, how much does it cost me in terms of meal? Like if I'm restaurant shopping,
$1.23.
you ever get that? If I want better decor, it costs me $1.23 per decor point. Right, so if I'm in a decor 10 and I want to be in decor 20, it's going to cost me $12 on my meal. Now, what if I'm in a service 10 and I want to go to service 20? What's it going to cost me? $22.50, $22.60. Right? So service is actually quite a bit more expensive than decor per point. So a lot of the cost of a restaurant meal, according to our model, is driven by the quality of the service.
The cost to the consumer, so the price.
Yep,
So the price.
the price. Yeah, the price to the consumer for a meal is, according to our model, driven. A lot of it is driven by either geography, right? Are you downtown or not? And then what's your service quality?
Right. And not the food cost.
And not the food.
That's based on this data.
Correct. And I think, right, and I don't know. So there's,
Generally, food is like 30% of your cost if you buy it, if you're in a restaurant.
But cost, this is really saying price, so cost is a confusing term.
well, yeah, sorry, it's a cost to the patron, right?
Cost of, so this
Yeah.
is price, not cost.
Well, and I think, right, and this is kind of the deal with this, right, is if I am getting lobster tails, right, I can go to Joe's Lobster Shack with garbage can lids and, whatever, and it's still going to be a fairly expensive meal, but this is not like a normal restaurant experience, right? That's the exception rather than the rule. These things just kind of tend to move together, right? If you're getting higher end food, you tend to be buying it at a higher end location, and this is really what's driving the cost for the most part.
So when you look at your charts over here, you got your
Yep.
self-relook.
Now, so these are going to start looking a little weird because I have a lot going, right? I have 5 variables happening at once now, so it's not going to be a line anymore, but yeah, I'm predicting, basically the reds are what I'm predicting and the blues are what I got in reality.
How come it doesn't plot it out as a line? How come it's like still a scatter?
Oh, sure. So, okay, so let's think about it this way, right? So if I have just, let's say I'm doing cost and food, right? It looks like this, right? So what if I add decor? Well, that would be like coming out of the page. So you can imagine if I had my VR goggles on, right? I've got my VR goggles on, and I'm looking out in the room. There's this cloud of points, right? And left, right is food, and north, south is decor, okay? And then the height up and down the z-axis, right, elevation, is food cost. So I have this 3-dimensional cloud. It's like a baguette of data, okay, right? And I have a line that shoots right through that baguette in 3 dimensions, right? But that's what happens when you have 2. So if you have 3 variables, you have a 4, right? I'm in 4-dimensional space, and so it stops looking like a, yeah. so we have a line through 5-dimensional space, and so it doesn't look like a line when we try to draw a picture. Okay, so there, and right in the little in-class thing where we have some of the restaurant ones, you can try on your own, those last little 4. So yeah, not graded, right? You don't have to at all. But if you got one to be green, then you would feel good that you knew what to do with actual data, right? Because you're going to turn around and do that in empirical project too, because it's basically this exact exercise, right? You're going to grab 5 variables from that opportunity atlas and do this kind of stuff with it. So yeah, at some point, if you want to, give it a shot. And the important thing, right, is if you're on that in-class thing and you're trying to do the food questions and it's coming up pink and you don't know why, that's a great reason to email me and we can talk about it.
Can we do the questions multiple times?
Yep.
I thought we were supposed to call you.
Yeah.
Yes. Yeah, you're right. But yes, if you get pink, you can just put a different number in and hit check again until it gets green. So yeah, again, so it's important. That in-class assignment is going to show up on your grade book as like something, but it's not, right? You'll get to see what your score is, but it is not affecting, it will not affect your grade. It will just show up in your grade book. You get me? With me? Because I can't make it not appear in your grade book. I can just make it worthless. So that's what I'm going to do.
Just, do you yourself, I mean, like if we were to call you at home or something to try to get help, do you use a Mac yourself or do you use Windows?
I personally have Windows, but I've helped people do this on a Mac.
Oh, okay.
Lots
okay.
of times,
Okay,
so.
good. All right.
The weirdest thing about a Mac is getting the stuff installed is a little wacky.
No, I mean, I
on
was
that.
mainly because I have Windows too, so I mean,
Oh, okay.
I was worried that you had a Mac.
Oh nope. I would completely ignore it except for my students tend to buy them. MacBook Pros look really cool. You know, they have that little bar that changes what it does depending on what you're doing all day.
It's got a light on the screen.
Yeah, and it looks like you spent a lot of money on it, which has its its own reward, I think. All right. Well, awesome. Thank you so much. So, let me stop the recording there. Stop the recording. What do?